All right, what is up, Brooklyn and Alex? This is round two of this. I got halfway through it just a few minutes ago, and for some reason my screen stopped recording. So I may back out of here and check it a couple times when I see the red dot in the top right go away. So today we're going to have to talk about integrals. So as we talked about at the beginning of calculus, there's two sides to calculus. There's derivative calculus, and then there's integral calculus. And we talked about how they undo each other. We talked about how like adding and subtracting undo each other, divide and multiply undo each other. Well, derive and integrate undo each other. So we've already been through all of the derivative rules. We were going to start in on derivative application. That's what we were getting ready to roll into, but hopefully if we get back to school, we can do that in person because that would be a lot easier. So what we're going to do is go through all of the integration rules through this, and then maybe when we get back to school, we can talk about application of derivatives and application of integrals all at the same time. So I'm going to take you through this. As you can tell from the title, antiderivatives. Basically, we're going to be undoing the derivatives that we may have already done. It's just going to follow similar similar form as what we have been doing. Similar structure is the word that I was looking for. Okay, so just like before, we're going to have some formulas and then we're going to apply them to some problems. So one of our first formulas is going to be the integral, oops, I'm on eraser. We're going to have the integral of 0. Okay. Now, think back to when we took derivatives. Also, let me pause for just a second. That symbol in front of my 0, that is the integral symbol. That one's a little rough looking. They'll get better as we go. But that is the symbol that you will see, and that tells you that you should be integrating. Okay. Now, also you'll see a dx after everything. And remember, sometimes we put dx. You really used to do it when you did implicit differentiation, and you did dy dx. But dx just basically means you took the derivative of something. So in order to be able to integrate it, we would have had to take the derivative at some point. So that's why you will see dx after it. So 0, okay, think about what you would have taken the derivative of to end up with 0. That would have been like the derivative of 5. Okay, so the whole number turns into 0. The derivative of 8, that would turn into 0. So there's no way for us to know what number 0 would have turned into. So what we like to do is we just call it C. C stands for constant, so it could be any number. It could be 1, 2, 3, it could be -10. So that's what you will use in that case. All right, so your second one. If we had k dx. Now in this instance, k is a constant number. I can't use c in both places, so I use k for constant down here. This is a number we know. So say, for instance, I have the integral of 3 dx. Right, so I've got to think, what would I have had to have as a derivative? What would I have been taking the derivative of to end up having 3 as my output for my derivative? So that would be something like 3x. So like f of x equals 3x. Remember, the derivative of that would have just ended you up with 3. So basically a constant number here, all we have to do is attach, oh, that is not good. Hang on. Let me fix this. Basically on a constant number like this, all we have to do is add the x to the end, and then what we want to do is say plus c after that, because it could have been any kind of whole number off the end. Say, for instance, I may have had f of x is 2x plus 3, and I wanted to take the derivative of it, so I'm finding f prime. Right, the derivative of 2x is 2, but then the derivative of 3 is gone, right? It turns into 0. So I can't say every time that 3 may not have always been there. So that's why we put plus c. And what makes me remember to do plus c is seeing dx. So basically when I saw k, I took the integral of it, and then the dx reminds me to put a plus c. So this is the reason that we've got to put that in there. All right, our third formula that we're going to run into is the integral of k f of x dx. This is a little bit wordy, but it's really pretty simple. It's basically saying like you have a whole number attached to some kind of function after it. And just like derivatives, that whole number is allowed to come out to the front, and then you can just take the integral of the function as it would have been. Okay. We'll do an example on it in a second. We had this one in derivative rules. If we have the integral of f of x plus g of x, we are perfectly allowed to integrate them separate. And that also works for subtraction, if you remember that from derivatives. One more. If I have, this is the main one. So the main power rule for derivatives was bring the number to the front and decrease the power by 1. So for instance, like the derivative of x squared, we brought the 2 to the front, it turned into 2x, and we decreased the power by 1. So we've got to be able to undo that. So if I have the integral of x to some power dx. Also, there should have been a little dx up here on number 4, but I forgot to put it. So if I've got the integral of x to some power dx, right? Think, to get the derivative, we subtracted 1 from the power after we brought it to the front. So what we need to do is we need to add 1 to the power, because we need to get it back up. But then the difficult part is, how do we get rid of that number that we may have put into the front? So we combat that by doing n plus 1 dividing by. This is going to make more sense in just a second, I promise. Don't forget we've got to put plus c. I also got to put plus c on number 4 too. I forgot it. Okay, so that's going to be the general power rule. That is going to come in example 2 down here. Let's just do a quick example. If I have the integral of x squared, okay, this is using rule number 5. To get the integral of it, I need to add 1 to the exponent, so that would be x cubed, and then I'll divide by adding 1 to the exponent. So this really turns into 1/3 x cubed, and don't forget about the plus c. You can write it as 1/3 x cubed. I'm probably going to write it as x cubed over 3. It's your call. So this is what the integral would be. And think about it. If we derive this, if we derive that integral that we just got, 3 comes to the front, 3 times a third is 1, and then the power gets decreased by 1, so it turns into 1x squared, which was the original problem that we just integrated. Okay, so this is how it works backwards and forwards. So let's do a couple examples. Example 1 is going to directly apply to rule number 2. Okay, rule number 1 is basic. It's just that. It's the integral of 0. It's c. It is always that. So there's not really any need to do an example on that because the derivative of 0, or sorry, the integral of 0 is c. So rule number 2 says if you have a constant number, you can just add the x to it and plus c. So basically, the integral of 3 dx is 3x, and then dx reminds me to add the c to it. Okay, so that is the integral. There's no reason, there's nothing else that you have to write with it. You don't have to call it anything because we're saying the integral of that is 3x plus c. Okay, moving over to number 2. Number 2, example 2, applies to rule number 3. So if you can see rule number 3 there, it's a constant multiplied by the function. In our case, in number 2, it's a constant 4 multiplied by the function x squared. So I'm perfectly allowed, I'm going to give myself some room here, I'm perfectly allowed to move the 4 to the front and then just integrate x squared dx. 4 is just along for the ride right now, so I'm going to go ahead and put the 4 in there, and I'm going to use rule number 5, which you can barely see there at the top of the page, to integrate x squared. So I need to add 1 to the power, so I've got x cubed, and then I'll divide by that, so it's also n plus 1, n being the power 2, so 2 plus 1 is 3. So a better way of writing this, if it was me, I would probably go 4, this one's not great to write. Your options are 4/3 x cubed or 4x cubed over 3. I really think 4/3 x cubed looks the best here, and then we will not forget to add c because of the dx attached to the m. Now, sometimes you got to make these look better before you can start them. For example, on example 3 over here, you know, rules of math allow you to bring things from the bottom to the top by changing the positive or negative on the exponent. So if I want to rewrite this number 3, I'm going to say it's the integral of 2x to the negative 5th. All I did was relocate this guy from the bottom up to the top by changing the negative on its power. And now this is something that I can integrate. I'm going to use exactly what I did in example 2. 2 is going to write out in front, and then I'm going to integrate negative 5. So 2 will be here. I'll integrate x to the negative 5th. dx, and it works the same way. So 2's hanging out. 2's hanging out. I've got to do x and add 1 to the power, so I've got x to the negative fourth, and then I divide by that. Now this one's going to work out nicely because I can reduce the fraction. 2 over negative 4 would be negative 1/2. So your options are negative 1/2 x to the negative fourth, but that still doesn't look great because we don't like to leave negatives in the powers like that. So I'm going to send it back to the bottom. So what I'm going to go with is negative 1 over 2x to the fourth. You can put the negative in the top, you can put the negative out front. I wouldn't put it in the bottom because it looks silly. Don't forget you had a dx, so you have to add in the plus c. So that is the best we can do for our integral. Got 2 more left. Example 4 directly applies to rule number 4. All right, so this is a couple different functions added and subtracted together. So basically it just means you can take the integral of 2x squared, you can take the integral of 4x, and you can take the integral of negative 3. This is just like derivatives. So we were able to break them all up and do it separately. So we'll do it here too. So when I integrate 2x squared, 2's really just riding along. I'm not going to put it out front this time. I'm just going to talk about it. 2's riding along, and then I integrate x squared. So that would be adding 1 to the exponent and dividing by the number. And don't forget 2 is out front. We'll make it look better here in just a second. 4x, 4 is really right. Oh, that is not good. 4 is really riding along here. So I've got 4, and then I would be multiplying by whatever the integral of x is, which is add 1 to the exponent and then divide by it. So adding 1 to 1 would be 2, so this is x squared divided by 2. Again, we'll make it look better in a second. Crap. Again, we'll make it look better in a second. Then I got the integral of negative 3, which would be more than likely just adding an x on it because that's a constant. So minus 3x. Let's make these look better. I'm going to go with 2/3 x cubed. In this one, in the second part, 4 over 2 is going to reduce to 2, so I can really just say plus 2x squared minus a 3x. I can't forget to plus c because that is the correct thing that we have to add on. Remember, plus c goes on any integral because it is always there. Could have always been a whole number at the end. All right, example 5 is another instance where we have to make stuff look better before we do it. I'm going to divide each of these separately. So I'm still going to be doing the integral. And I'm going to go x cubed over x cubed, minus 2x squared over x cubed, and then plus 5 over x cubed. And I'm going to start reducing stuff. So that front guy, it's easy. It turns into a 1. But on the second one here, we have more exponents on the bottom. So I'm going to have 2 over x probably, because I have 2 on top and 1 on the bottom. And then on my third one over here, it can't reduce at all. I've just got 5 over x cubed. But I still don't know how to integrate things that are in the bottom. So I'm going to use that rule like we did up there on example 3 and bring it back down, bring it up to the top and then go from there. So I'm going to integrate 1 minus 2x to the negative first because I brought it to the top. And then I got 5x to the negative third. All right, I've got a whole number here in the first one, so that means I just have to add an x to it. Oops, this is not the integral anymore. This would be an equals because we are actually integrating at this point. On the second part here, I've got a negative 2's just riding along, and then I've got to add 1 to the exponent, which would take it up to 0, and then I've got to divide by 0. So that's not really a thing, okay? So this is something that we're going to talk about moving forward. There's something special about 2 over x, and I didn't realize that was going to be in this problem before I started it. That's a rule that's going to come up in a couple days from now. We'll end up talking about it at some point. So I'm going to leave that out for right now. Let's just pretend that part is not part of this problem, okay? Because there's a certain way that we have to do that. And then we'll just finish out with the last one. So 5x to the negative third, I've got 5 is just riding along. X, the negative third, goes up to the negative second, and we got to divide by that negative 2 also. Okay, so if I want to finish this out, I got the x from the front. Remember, this part we decided to leave out because I'll talk about it in a few days. And then we've got what looks to be negative 5 over, because this x squared is going to have x to the negative second is going to have to go to the bottom. So I'm going to call it 2x squared on the bottom. Okay, don't forget, got to add in c because that makes it all even. Okay, so this is our first lesson. Hopefully this went okay. Let me know if you need anything different or if it didn't make sense or something like that. Use your formulas. The assignment that we're going to do going along with this will be page 287, numbers 11 through 22. 22 is a little bit of a challenge. It's something squared. I think you'll be able to figure that out. It's not bad. You just have to FOIL it and then go from there. Don't forget to add in your plus C's. Once again, let me know if you need anything. Hope this worked well. I'll see you guys soon.